Hey guys, just to let you know that you can catch these lessons live every Thursday from 6 PM until 7 PM UK or BST time, and that will just allow you to ask any questions that you want and get some answers to them. Without further ado, let's get on with the lesson.
Okay, hello and welcome back to another one of the A-level revision tuition classes that I'm doing on YouTube. So last week we went through differentiation, and the week before actually. So whenever we have a operation in maths, so times, divide, add and subtract, we need to have the inverse operation. So for differentiation, the inverse operation, as you can probably guess, is integration. Okay, so just as a recap, if we have a curve, let's say it's y is, make it nice and easy, x cubed plus x squared plus x plus 1, then if we were to differentiate this, we bring the power forward and we subtract 1 from the power, right? Nice and easy. And then if it's a constant, it goes away. So with integration, what we want to be able to do is get back to the top part, okay? So essentially we're just undoing what we did with differentiation, okay? Now you might ask yourself, okay, so when we took the second derivative, right, that could tell us kind of the nature of turning points, right? So if we have dy by dx, it tells us an equation for the gradient. If we equate it to 0, we can find out where the gradient is 0, and we call those turning points. If we differentiate it again, we can find out if those turning points were maximum, minimum, or points of inflection. So with integration, if we integrate the top thing here, it gives us the area between, so if I were to draw a nice curve here, right, it gives us the area between the curve and the x-axis. Okay, so a lot of people say that integration gives you the area under the curve. It's not technically under, it's just between the curve and the axes, because as you can see here, it's actually above the curve. Okay, so integration can give you a few different things. So what we should do first is figure out how we do integration. Okay, so when you integrate something, right, and I'm just going to do this. Let's say we're integrating this expression here. The notation is a bit strange, okay? It looks like this. So you have this kind of long s at the beginning, and we end with a dx, or whatever you're integrating with respect to. Okay? And now what we do is we do the opposite of differentiating. So let me show you what that looks like. If we were to differentiate something, so if y is equal to x to the power n, axn, then dy by dx was equal to an x to the n minus 1. Okay? If we integrated it, so the integral of ax to the n, what we do is we add 1 to the power, so we have x to the power of m plus 1, and we divide the whole thing by the new power. So can you see how that's the opposite? Instead of bringing the power forward first, we bring it forward afterwards, and instead of multiplying by the power, we divide, and we add 1 to the power instead of take 1 away. Okay? And then at the end, we also have a plus c. And I'll show you why we have a plus c in a second. So we're integrating this dy by dx, and what we should get is y. So we have 3x, add 1 to the power makes it cubed, and divide by the new power. Plus 2x, add 1 to the power, divide by the new power, plus 1. Now, if you have a constant, all you do is you add an x on the end. Because x to the power of 0, add 1, you get x to the 1. Divided by 1, you just get x to the 1, so it's just x. Now, if you have a look, so now let's simplify this, right? So we have x cubed plus x squared plus x, right? Now, if we compare this to our original equation, it's really, really close, right? Which is good, but the thing is, it's not correct yet. So we also have to introduce a plus c. Now the thing is, I don't know what this plus value would be, right? It could be plus 1, but it could be plus 2, 3, it could be negative 10, it could be anything. So because I don't know what it is, I have to put a plus c. And this is the problem when you differentiate and integrate, is you do lose some information, right? When I differentiate this, the 1 just disappears. It vanishes. So when I integrate, I have to introduce this constant plus c. And in every single integration question, you have to have the plus c. There is an exception to this, okay, where you sub in values to find out what it is. So in order to find out what that is, what we would need to have is we would need to have a coordinate that exists on this curve. Okay? So for example, I know for a fact that when x equals 0, y equals 1. So if I subbed in x is 0, y is 1, I could then figure out what the value of c is. But you have to introduce the plus c whenever you integrate. Okay? Now this gives me essentially an equation to work out the area under the curve. And the way you work out the area under a curve is you need to first introduce your bounds. So let's say this was -2 and this was +3. And what you're doing is you're integrating with the limits -2 to +3. And you integrate your expression. And that will give you the area between the curve and the x-axis. Okay, so that's a very brief summary. But we're going to do some example questions now. So, first one's hopefully should be quite easy. Find the integral of this whole thing. So we're integrating 2x cubed plus 5x squared minus 7x plus 10. And then again, this dx just means with respect to x, so we're only counting x variables. So we have 2x add 1 to the power 4 over 4 plus 5x add 1 to the power divide by the new power minus 7x add 1 to the power over the new power plus 10x, again that would be divided by 1, so I'm not going to bother, plus c. This plus c will drop you marks if you don't include it. Now we just simplify. So 2 over 4 we can just replace that with a half x to the 4 plus 5 over 3x cubed minus 7 over 2x squared plus 10x plus c. Nice and easy. So again, these can be kind of 3 or 4 mark questions, so hopefully you can kind of get those extra marks. Again, similar thing. Add 1 to the power and divide by the new power. Add 1 to the power, divide by the new power, minus 2x, and then don't forget the plus c. So again, we are going to go through a few of these basic examples, but we are going to get on to some more interesting exams. So these are all exam questions, but we're going to get on to different styles of questions a bit later, so feel free to skip ahead in the video or the live stream. Well, obviously you can't skip ahead in the live stream, but skip ahead in the video if you want to see some of that. But again, it's good to go over the basics, because the more you write this plus c, the more likely you are to remember the plus c. Okay. Now for this one, we can't integrate when it has brackets, okay? Because this is a product of 2 terms, okay? So what we need to do first is expand the bracket. So this would now become the integral of x times x is x squared plus 4x minus 3x, so plus x minus 12. And again, if we add 1 to the power and divide it, I'm just going to do it in one step, but hopefully you can check to make sure that's okay. Again, whilst you're learning, it's good to go through all of the steps one by one. But again, hopefully, with things like this, when there's no number in front, it's quite easy just to solve that. Okay, so if they ever give you a point, that means you need to get rid of the plus c. You need to figure out what plus c is. So here, f prime x, so we have dy by dx, is this. We need to find f of x. Now f of x is just going to equal the integral f prime of x. Okay. So again, I'm writing it very formally. You don't need to write this in your exam, but I'm just making sure that you all understand exactly what we're doing and why. And let's see what happens here. So 6x cubed over 3 minus 3x squared over 2 plus 8x plus c. Okay. Now what I'm going to do is I'm going to simplify this first. So now we have f of x equals 6 over 3 is 2, 2x cubed minus 3 over 2 x squared plus 8x plus c. Now, again, some students leave it here and they don't get the full marks. You now need to find out what c equals. There can be only one letter in your answer. So we know that when x equals 1, y equals 8. Or rather, I should write f of x, but I haven't in this case. So 8 equals 2 times 1 cubed minus 3 over 2, 1 squared plus 8, 1 plus c. And then all you need to do, I can show you a bit of a shortcut, is on a calculator, if you want to be really kind of lazy, is if you just do 8 and then change the signs of all this, it will give you the right answer. But, I mean, another thing we can see is these two things will cancel each other out, right? So what we have is 0 equals 2 times 1 is going to be 2 minus 1.5, so that's just a half plus c. So c is equal to negative a half. So our actual expression for f of x is just equal to 2x cubed minus 3 over 2 x squared plus 8x minus a half. Okay. So again, this is just for the AS stuff at the moment, but we will get into A2 fairly shortly. So just so you're aware, there are vectors and proofs, and then we're going to go on to mechanics and statistics, and then we're going to go on to the A2 content. So sometimes they can, again, just like with differentiation, we can't really differentiate or integrate when there are square roots or there's indices that are like on the bottom of a fraction. So the first step is always going to be changing this into proper indices. Okay. And now this is actually where I find a lot of people make mistakes, because again, this kind of integration, once you get into A2, comes across quite easy, right? Which is good. But it's also very easy to make mistakes when you're adding one or taking away one from fractions. I know that might sound stupid, but imagine you're in an exam, right? I know you're smart enough to add one to a fraction, but it's also very easy to make a mistake if you're kind of rushing, right? And in an exam, you're probably going to be rushing, you're under pressure, easy to make a mistake. Just be really, really careful. Not just that, if you do a lot of practice, you'll get used to adding one and subtracting one from like halves and thirds, because those are the common ones that they give you. So we have 4x. A half plus 1 is going to be 3 over 2, but again, don't be afraid to write down the working out. Now we're dividing by 3 over 2, so timesing by 2/3, but honestly, don't even worry about that. Just do 4 divided by 3 over 2 on a calculator. Don't take risks. And then plus x minus 1 over minus 1. Don't just leave it as plus x minus 1, because it's actually going to become minus x minus 1, okay? Again, this is something that happens all the time. I've seen it from really bright students. So now if we solve this, again, I'm not even going to take the risk. I'm just going to use a calculator because, again, we need to be clever about this. 4 divided by 3 over 2 is 1.5. Gives me 8 over 3, so I'll just leave it as that. Okay. And then minus x to the minus 1 plus 10x plus c. So again, with these questions, technically speaking, I didn't have to simplify because it doesn't say to simplify. However, these questions are slightly old, if I'm being honest with you, because ever since they combine the exams, so you just do them all at the end of A2, these kind of questions don't come up as much. There are questions later on where it's about areas under graphs, well, areas under a curve. That does come up now. This comes up, it does still come up, but just not as much. So to fill out the lesson, I did take exam questions from earlier years. They didn't actually specify to simplify, but they did expect it. Now they literally do say leaving your answer in its simplest form. So just be aware that you will have to simplify your answers. So again, we're going to come on to slightly trickier questions in a second, in terms of like calculating areas under or between curves as well. That's one thing they like to do. Now this, it's again slightly different, but the first thing you need to do is again expand these brackets. Okay, so x squared plus x minus 12. Now I didn't actually show you what you need to do when you have limits, because I wanted to save it for this question. So first thing you do is you integrate like normal, okay? So this would be, this would be a third x3 plus. Now I'm going to still put the plus c, Right? Now that might sound a bit weird to those of you that are just seeing this for the first time, but for those of you that have seen this before, you'll know I don't need to write the plus c when I sub in limits. Okay? The plus c, because think about it. If I sub in limits, I get an area. An area shouldn't have a letter in it, right? It should be 10 centimeters squared plus c. That doesn't make any sense. But I'm going to show you why the plus c is actually irrelevant, right? We don't just get rid of it because we know it's an area. We get rid of it mathematically. Now what we do, okay, and I believe certain calculators actually can do this for you, but, you know, is you sub in the top limit first. So what I'm going to do is I'm going to put this in big square brackets. And in the first square bracket, I'm going to sub in x equals 3. So we have 3 cubed plus a half, 3 squared minus 12, 3 plus c. And then I take away the second substitution, okay? Because what this is giving us is, I can actually explain it in a bit more detail now. For those of you that are interested, if you're not interested in exactly where the maths comes from and you just want to, you just want to get your A level and get out of here, it's completely acceptable. When you do this integration, right? So let's say if it's like something like, right? I need two limits because I need to define a start point and an end point, right? So let's say this was 1 and this is 3. I know it doesn't look like it. Because what this will do is it takes the area under all these bits, right? So it takes the area up to 3 from negative infinity. So if I only have one limit, my integration becomes infinite. Because my area is all the way from the left-hand side all the way up here, right? So it's undefined. When I define a lower limit, I take away everything from that number 1 backwards. So I'm only looking at between these 2 points, okay? That's why we subtract the lower limit, okay? So again, that might just be interesting for those of you that care about the maths. If not, it really doesn't come up much, or at all. And if you see, I have a plus c minus c. These terms will always cancel out because there's never an x with the c. So I never substitute anything different. So I can always just get rid of the plus c. Now again, on your calculator, you can work out the first bracket and the second one and subtract it or do whatever you want to do. I'm going to do it properly, but you can also just sub the whole thing in your calculator, right? So if I do open bracket, the only thing I will say with doing this is that you're more prone to error. So take it slowly. Whoops. And the reason why I say that is because you're not going to be able to see everything you're typing in a calculator, because again, this is very, very big. Okay. So I apologise, I've bought myself a new keyboard, and like certain keys are in different positions, which is really annoying. And then again, subtract. So can you see I've already lost track of what's at the beginning? So what you can do is go back and say, okay, this looks exactly like that. Or again, you can do the two brackets separately and subtract them. So again, I'm going to show you how to do this all in one step as well, okay? But bear in mind that they do expect working out for this question. So if you want to check your answers, for example, is if you look at this button here, that's the integration button. And using the X key here, you can actually sub in exactly what it needs to be. So I'll show you how to do that as well. But again, use it to check your answer because they will expect working out. And that's it. So minus 34 over 3. So you might think, wow, a negative area seems a bit weird. Not in integration, okay? In integration, a negative area simply means that the area is under the curve, okay? So areas like this are positive. Areas under the curve are negative, okay? This is a really, really important fact, okay? A lot of students forget this. The reason why this is important is if I wanted the total area, right? Let's say this was -4, this was -2, and that was +3, yeah? if I wanted the total area under the curve and I integrate from -4 to 3, the positive area and the negative area will partially cancel out or completely cancel out. You might get a 0, which obviously isn't right. So instead you'd have to integrate from -4 to -2, find that area, then -2 to 3, and add them together but as positive numbers. Okay? So that is something else you should keep in mind. If you have parts of your curve above and below the axes, if you want the total area, you need to do them in stages. Okay. Again, something that should be fairly simple by now. Well, I'm hoping anyway. You need to integrate 10x to the 4 minus 5 dx. So that will be 2x to the 5, right? 10x to the 5 divided by 5, so 10 divided by 5 is 2, minus 5x plus c. And then we know that the point 230 lies on it, so when x equals 2, y equals 30. So that will give me 30 equals 2 to the 5 minus 5c. So we can just basically sub that all in on a calculator. So we have 2 to 5 minus 5 times 2 is 10, so 54, so 30, whoops. 30 equals 54 plus c, so c is equal to minus 24. So that means my equation for y, or expression, is this. Not too shabby. Again, we have another integrating between a certain range question. So once again, change this into the proper limits. Sorry, not limits. The indices, so that would be minus a half dx, 5x, and see, this is where things can get a bit tricky. You have x to the plus a half now, over a half. So plus x to the half. Cool. And again, you can just solve what that is. Let's just do it properly. So 2. So I know these questions can be tedious, but they tend to only come up like once in the paper, so you don't ever have to write out this huge amount of stuff over and over again. And perfect, let's go. So 5 times 4, so we have in the first bracket we have 20 plus 4. I could have just done that in my head, but yeah. And we have 5 plus 2. Well, yeah, now I look foolish. We have 24 minus 7, which is indeed 17. Okay, so again we're keeping it fairly simple. This is where they can kind of introduce some kind of setbacks. So as you can see, it's slowly creeping in difficulty, but it is a fairly slow difficulty curve that I'm trying to take you through. With this one, we have to do the division first. So this can sometimes catch people off guard, because again, 2 minus a half, I've seen A2 students get this wrong, so it would be 3 over 2 in this case, because it would be 1.5. I've seen A2 students get this wrong. It's very easy to make a mistake on, so please try not to. Take it fairly seriously. And then we need to integrate. Cool. Five plus 3x. So we get 5x plus 3x to the 5 over 2 over 5 over 2 plus 2x to the positive half now over a half plus c. So again, we can simplify this, and it doesn't really make a difference not to. So 5x, 3 divided by 5 over 2, so it'd be 3 times 2 over 5, which is 6 over 5, so C. And then again, we have that f of 1 equals 2, right? So when we sub in x is 1, we should get 2. So we have 2 equals 5 times 1 plus 6 over 5, 1, 5 over 2, plus 4, 1 half, plus c. So that becomes 5 plus 6 over 5. Okay, that's slightly annoying to do in my head, so I'm going to do it on a calculator and be lazy. So we have 5 plus 6 over 5. That's just 1.2 actually, it's not that bad. Yeah, 51 over 5. Or 10.2. Let's leave it as 10.2. So C equals 2 minus answer. Negative 41 over 5. Or just, to be honest, we tend to use fractions, so let's leave it as a fraction, even though it's absolutely hideous. And that would be our answer. So again, these kind of questions can be are 4 or 5 mark questions. So although it's a bit tedious, it's actually not bad for the amount of work you have to do, which is, good. Here we come to the magnum opuses. So this is where things get a bit trickier, okay? So a little bit trickier. This is where we have areas under curves. However, if you have a look, it's not the complete thing. So if we think about a few things, part A just says, so again, this is where things are going to get a lot trickier. These are the hardest questions. Again, if you can look, 2 and 6 marks. Some of these are worth 8 marks. Okay, as in not in total. I mean, just the second part is 8 marks. Okay, huge numbers of marks, huge, huge, huge. So, if we start, it kind of breaks it down for you. Find the coordinates of the points where the line intersects the curve. Okay, so when 2 lines or curves intersect, it means that both of their expressions are true at the same time. So y equals y. So in this case, 4 is equal to all of this. So we have 4 equals x, 5 minus x. Now to work this out, we're going to have to expand the bracket. So we have 4 equals 5x minus x squared. Now this is a quadratic, so when we solve it, we're going to get 2 values of x, right? Which is good because we can see that it meets twice. So getting 2 answers makes sense, okay? So if you manage to solve this and only got 1 value of x, you know immediately something's wrong. So if we shove everything to the left-hand side, we're going to have x squared minus 5x plus 4 equals 0. If we're being lazy, we could 2 numbers that times 4 make minus 5. So actually that's not too bad. It's just minus 4 minus 1. So our brackets are just x minus 4, x minus 1. And again, you can use the quadratic formula just to get the answer straight away. No harm, no foul. So our 2 values are x equals 1 and x equals 4. And again, if we look back at our graph, it kind of makes sense, right? That 1 would be here, 4 would be here. Now, the y coordinate should be obvious, right? Because the line is just y equals 4. But if you're unsure, you can always sub it in. So y is now going to equal, for this left-hand side, it's going to be x, so that's 1 times 5 minus 1, which shockingly is 4. Subbing in 4 as well, you get y equals 4, 5 minus 4, shockingly is 4. So our 2 coordinates are 1, 4, and 4, 4. Again, you don't actually need to sub it in to find what the y value is, if it's obvious from the fact that the line is y equals 4, okay? Now here's where things get a bit more interesting. It says, find the area of the shaded region R. Now, what I normally see people do, and this will get you 4 of the 6 marks, okay? Not bad, not bad. 4 of the 6 marks if you just integrate this curve between the limits of 1 and 4, right? So if you just did, and again, we expanded this, so I want to use the expanded version, 5x minus x squared, right? That will get you 4 marks out of 6 because, and this is the problem, is if you do that, you also include all of this area, okay? Which is a mistake. The last 2 marks come from working out the area of this rectangle and taking it away from your integration. That's where you get your last 2 marks, okay? So the width of this, it goes from x is 1 to x is 4, so that's a width of 3, and the height is 4. So the area of that is 12, right? So what we can do is then write minus 12, which is just the rectangle. And that will give us our final answer. Okay, so that gives you 2 marks, just writing 12 basically, right? Because the width is 3, height is 4. So we're going to be really careful of that. Again, this isn't too bad of an example. There are some other questions which are a lot more brutal. But hopefully you can see the tricks that they can pull with you. So, let's do the integration. So that'd be 5x squared over 2. So I'm just going to write 5 over 2 x squared. And that will just be minus a third x cubed. But between the limits of 4 and 1, and then again minus the 12. So this gives me 5 over 2 4 squared minus a third 4 cubed minus 5 over 2. And this is the most fun of any integration question, is writing this long working out. And again, I'm just going to set this all on the calculator because I'm being a bit lazy, but let's do it. So we have 5 over 2, which is 2.5, 4 squared, and minus a third, I can't really do as a decimal properly, 4 cubed. And the arrow keys are what I've moved on the keyboard as well, which is a bit awkward because I keep pressing the end key instead now. Minus 2.5 times 1. Again, I probably don't need to put the brackets for this, but you know. I really didn't need to put the brackets. Okay, but, you know, is what it is. Cool. And then the minus 12 on the end. 9 over 2, so 4.5. Okay, that gives you the full 6 marks. And again, if you look at the work we did, 6 marks for 3 lines of working out and an answer. It's not bad, but again, it's relying on you understanding what this means and what it means when you integrate something. Do you remember? Do you remember what I said? 8 marks this time. Okay. So write down the value of x where the curve crosses the x-axis. So for it to cross the x-axis, that's the x-intercept, right? So x-int. That is when y equals 0. So we have 0 equals x, x minus 2, x minus 5. So that happens when x equals 0, x equals 2, x equals 5. Nice and easy. So again, it goes to the origin, that makes sense. That must be 2 and this must be 5. So in these types of questions, you also have to apply your logic, because when you have these indentations here, if you put 5 and then 2, although it's like, oh, it's not drawn accurately, put 5 and 2 there, you're going to get the wrong answer. So you need to make sure you're putting the numbers in order in a way that makes sense. Negative answers will go on the left side, positive on the right side, okay? And this is an 8 marker. Now let's have a think about why it would be so much. Now if you remember, when you integrate when it's underneath the curve, you're going to get a negative number. If you integrate when it's above the curve, you get a positive number. So to find the area of the shaded region, you need to integrate twice. Okay, between 0 and 2, which will give you a positive number, between 2 and 5, which will be negative, you make that value positive and you add them together. Okay? Because if you just do from 0 to 5, you're going to get positive and a negative mix, which means you get a smaller overall answer. In fact, you'll get a negative answer overall, but it won't be the correct one. So we need to integrate this thing. Well, the first thing we need to do is expand the brackets, right? Which again is where some of these marks come from. So x squared minus 2x minus 5x and minus 7x plus 10. That's x cubed minus 7x squared plus 10x. Now I'm going to integrate this firstly between the values of 0 and 2 and do that. Now I'm going to remember the integration result because I'm going to be doing the same thing just with different limits later on. So if we integrate this, we're going to get add 1 to the power and divide by the new power. So that would be 4 divided by 4, so a quarter x to the 4 minus 7 over 3x cubed plus x squared. So divide by 2, it's going to be 5x squared. Now again, I can use my logic, right? Because you know how we normally sub in 2 sets of brackets, the 2 and the 0. If I sub in 0 to this, I get 0. So I can just sub in the 2. Okay? Be careful, that's not always the case, but in this case it's 100% fine. So for example, when you get into A2 integration, you're going to be integrating sine, cos and tan. Sine of 0 is 0, sure. Cos of 0 is 1. So be really careful with that, okay? So perhaps don't get used to just, if it's 0, you can just not do it. You have to be very careful, you have to be smart. In this case, if I test it out, if I sub in 0 to all of these things, I get 0, 0, 0, so I don't need to do it. But that's not always true. So, we're going to do 0.25, a quarter, to the power of 4, pressed end again, dang it, minus 7 over 3, 2 cubed, plus 5, 2 squared. Looks right to me, so 16 over 3, cool. Now we need to integrate between 2 and 5. Now, here's the thing, right? The lower number always comes first. Kinda? So I'm just going to copy that exact same integration, right? Because the integration is going to be the same. But 2 is now at the bottom and 5 is at the top because we're going from 2 to 5. Okay? This will be negative. So what some of your teachers may have taught you is to flip the limits. So if I change this to between 2 and 5, right, it just means it's going to be negative. Okay? So here's a tip for you. If you flip the limits, you get the negative of what you had before. So some teachers prefer to teach just to flip the limits and you'll get the negative answer. I don't like that because I think it's just needless, right? But if you flip the limits, you just get the negative, you get the opposite, which should make sense, right? Like if I did 10 minus 3, I get 7. And if I do 3 minus 10, I get negative 7. So the only difference is the minus sign. So hopefully that does make sense that that does indeed work. But again, it doesn't always work. Okay? Well, it does always work, but again, it's not always needed, right? If I just know I'm going to make it negative, then I'll just make it negative. Okay? So hopefully that makes sense as to why that works. And again, we're doing the same thing. So, with your permission, I'll write it out. God, I'm really lazy today. 5, 4. Again, normally in questions like this, it's not too bad because you only have like 1 per paper. When you have to study this though, that's when things get a bit annoying. And yeah, I know, you guys are the ones studying it and you guys are going to be doing this a lot more than I have. But I've done these questions about 1,000,000 times now. There we are, okay. And again, super long, super tedious, but again, it is an 8 marker, so we need to expect to do a little bit of legwork. But hopefully that makes sense. Again, we're not finished after this though, just keep that in mind. So, what I can do, okay, what I'm going to do is I'm going to reuse this. And, I see what we can do. Okay, I've had a brainwave. Since we already have the result for subbing in the 2, we can just sub in this and then just subtract 16 over 3. That's valid too. I still need the brackets though, so that's fine. right? So if I put that in brackets, and now if I subtract the 16 over 3, I get minus 63 over 4. So as I said, I'm getting a negative number. So if I integrated from 0 to 5, I would cancel out part of the area, but that's not what it's asking. It's asking for the area of the shaded region, which means I need to add these together, right? So the actual area is 16 over 3 plus 63 over 4. Remember, the negative just means it's under the x-axis. Okay? Areas can't actually be negative, right? So what I'm going to do here is I'm going to do... Oh, okay. 16 over 3 plus 63 over 4. And that is my actual answer, 253 over 12. And because it hasn't told me to round it, I'm not going to. And again, what would that be? Centimeters, meters? Honestly, honestly, they don't normally ask for a unit, but because we don't know what the units are, we can just write units squared if we want to be really technical. Because again, it's a graph, it doesn't actually have centimeters, meters, or anything on there, but we can do that. And the next one is probably the hardest question, so hopefully you're all okay with that one. Pretty tedious, but again, 8 marks. That's a lot of marks, okay? And again, the maths isn't that difficult, but it is easy to make a mistake, so please, please, please be careful. And the next question is the last question, unless one of you guys want to post a question, and I'll answer it on stream as well. But if not, let's get to it. We have 2 lines here. Find the coordinates where the lines intersect the curve. So once again, for these to intersect, they need to be equal to each other. So what we're doing for part A is we have 2x equals 10x minus x squared. What I would do here is I'll divide the whole thing by x, so we get 2 equals... Actually, you know what? Before we do that, if we bring everything to one side, so minus... Let's move everything to the other side, so we have x squared. Thank you, understand physics. And minus 8x equals 0. So in this case, you might be tempted to divide through by x, which you can do, but you need to remember you're actually getting rid of a solution, because keep in mind, we have 2 points of intersection. So if you factorize this, our 2 values are x equals 0 and x equals 8. So in the beginning, I was going to divide by x. That's fine, but know that whenever you divide by x, one of the solutions will be x equals 0. Okay? So we have those 2 values, but we want the actual coordinates, so we want the y values too. So all we're going to do is sub in x equals 0 to either equation. So if I sub it into here, when x is 0, y is 0. Nice and handy. And when x is 8, y would then be 16. Again, it doesn't matter which equation you substitute it into, because it's going to give you the same thing. So that's part A, but obviously we're here for part B. Now this is where things get a bit more tricky, okay? Because if we were to integrate just the curve between, actually let's label the points here, 0 and 16, I would also add all of this area here, okay? So what we can do is similar to this part, where we, sorry, not this one up here, we integrate between the curve and then subtracted the rectangle, right? Well, if I look here, now that I've shaded it in, it's just a big triangle. And in fact, it's a right angle triangle because the x and y axis are always perpendicular to each other. The height of this, well, the y coordinate is 16. Whoops, that's my bad. That's not going to be 16, that's going to be 8. So the height of this would be 16 and the length would be 8. Okay? So we can just subtract the area of a triangle, right? The other thing I've seen some people do, which works perfectly fine, is to integrate this line between 0 and 8 and subtract it from the curve, which it will give you the right answer, that's completely fine, but it's a bit unnecessary, okay? So the area of this shape here is just going to be a half times 8 times 16, so that's 4 times 16, which is 64. So all I'm going to do is subtract 64 from my integration. Okay, so again, this requires a bit of problem solving, a bit of logic, which is why a lot of students find it very tricky. So with part B, all we're going to be doing is integrating between 0 and 8 the expression 10x minus x squared, and then at the end we're going to subtract 64 from it. Cool. So let's get to it. So again, we've done quite a few examples of these. We add 1 to the power and divide by the new power. And again, add 1 to the power, divide by the new power. We don't need the plus c because it's going to cancel. And let's simplify this quickly. We have 5x squared minus a third x cubed between 8 and 0. And again, I'm going to show you a bit of an advanced technique. Not advanced really, but normally we substitute in our values, right, like we did up here. However, if I'm subbing in 0, in this case, again, not in every case, sometimes, again, in A2, when you come across sine and cos integration, cos of 0 is 1, it's not 0. So, when you sub in 0, make sure you do sub it in, but for this expression, can you see that if I sub in x is 0, the whole thing is just 0? So I can get away with just subbing in x is 8. So 8 squared minus a third, 8 cubed, and then minus 64. Okay? Because again, if I subbed in 0, I'll just have an extra minus 0 in the middle. Okay? So again, not too bad, not too bad. But again, it can catch people off guard. So again, go back to our calculator. Let's use 8 squared and minus a third. I'm going to have to use the fraction button. 8 cubed. And again, let's put the minus 0 anyway, just for completionist sake. 256 over 3. Again, leave our answer as a fraction. Technically, we don't have any units, so you don't have to write anything, but if you want to be really meticulous, you can write units squared. And again, it's positive because it's above the x-axis. Everything below the x-axis would be negative. Okay. So that's all the questions I had for today. So we've done a ton of these. It comes up slightly less than it used to. However, this type of stuff still does come up a decent amount, so it's worth knowing. However, they might chuck in A2 integration, like with cosine or sine or something like that. But if you all understand that, we can finish for today, but I'm going to leave it open just for a second if you have any questions or you want me to go through a question. You can do that. Okay, I think that's everything for today then.